This will be a review video going over non-comparison based sorting algorithms. So we're going to start off with a bucket sort. I would say it's one of the most straightforward of the non-comparison based sorting algorithms. Essentially what it does is it creates n buckets of even ranges, and then it's somewhat of a comparison based algorithm, I would say, because it uses insertion sort to actually sort the buckets that we have. So it generally runs in O of n time, but the caveat is that the elements in your original array have to be uniformly distributed. Otherwise, it could be as bad as O of n squared. What this essentially means is if we have 100 values between the numbers 0 to 10, and then we have one value that's like 201, we don't really have a uniformly distributed original array. So we would have one bucket that had many different elements, and we would have to sort it using insertion sort, and then our runtime would go to O of n squared. So let's go ahead and try sorting this example that we have here. So first we create n buckets with an even range, and then our second step is to put each element from our original array into the appropriate bucket. So, as you can see, our first value, 87, will go into the 80 to 89 bucket. Our second value, 34, will go into the 30 to 39, and so on until all of the values from the original array are put into one of the buckets. As you can see, some of our buckets don't have just one value in them, so this is where we'll run insertion sort to sort these buckets. So now all of our buckets are fully sorted. So all we have to do is put all our buckets together into a new sorted array. Okay, so going on to counting sort. So counting sort has more space complexity because it uses two extra arrays, one for counting and one for holding the sorted solution. It also runs in O of n plus k time, where n is the number of elements in our original array and k is the range of these elements. So for this example, let's sort this array down below. In this, our range is from 0 to 8 because our largest number here is 8 and then our smallest number is 0. So that makes our k 9. So once we have this, we want to count how many of each of these numbers appear in our original array, and then we want to record it in the counting array. So as you can see, there's only 1 0 within our original array, so we put a count of 1 there. There's two 2's in our original array, so there's a count of 2, no 1, so count of 0, and so on. So once we do this, we want to start from the beginning of the counting array and add the counts up as a cumulative sum. So we'll start 1 plus 0 equals 1, so this 0 will be replaced by a 1, the 2 will be replaced by a 3, the 1 will be replaced by a 4, and so on until we go through the entire array. Once we've done this, our last step is to set up an array the same size as our original array. This is because this is where we'll be storing our sorted solution. So once we do this, we're going to start from the end of our original array, check what number it is. As you can say, we'll check that it's 8, and then we'll go to our index at that number in our counting array, and then we'll decrement the number that's in that value. Once we do that, that will give us the index of that original array item, and that will be placed in the sorted array. So we'll go to index 6 of our sorted array and place 8 in there. Now, we'll go to our next element that we're going to be looking at, and that's 5. So we go to the index of 5 within our counting array, and then we will decrement that number to 4, and that'll give us the index at where 5 would be in our sorted array. And we would continue doing that until we were fully done and had a sorted array. And finally, a sorting algorithm we'll be talking about is radix sort. So braided sort uses counting sort to sort, and it's great for numbers if k is smaller than n, where k is the max number of digits the element has and n is the number of elements. We can see one of the good examples for braided sort is sorting social security numbers, because social security numbers always have 9 digits, and we can sort a large amount of them with braided sort. So let's try sorting this example below. With the braided sort, instead of doing sorting on the entire number, we'll sort by each digit. So the first step we have is sorting elements by the ones place digits. We'll run counting sort on this and it will sort those digits in order. And as you can notice, the order is preserved in this. 300 came before 90 because 300 was first in the original list, and this is what makes this algorithm a stable sort. So once we do this, we're going to sort the elements by the tens place. And if there's a scenario, for example, the 9 in our array here, if there's no tens place digit, just use a 0. Once we have that, we have sorted all our elements. And then finally, we'll sort elements by the 100th place digit. Once again, if there's no 100th place digit, just use a 0. And once we do this, we'll have our array completely sorted. If we had numbers larger than this, then you would just continue on until we've hit the last digit, 1,000, million, and so on. So yeah, we have a final sorted array. That'll be pretty much all for this video. Thanks so much for listening.